Hello, my name is Ondřej Mirtes, and I like pointing out mistakes in other people's code so much that I created a static analyzer that does it for me. So, who uses PHPStan? Yeah, great, almost everyone. So, I would like to spend a little while on introducing it, in case if you are not familiar. So, compiled languages need to know type of every variable before the program runs. They won't let you run an application with an error like accessing an undefined variable or call to an undefined method. But PHP isn't compiled. PHP is interpreted. So PHP will let you have these errors in your code, and it will complain about them when the line with the error is executed. So PHP developers can spend a lot of time uncovering mistakes that wouldn't even compile in other languages. And when I was studying at a university, I was forced to work with Java, but I was a PHP developer at the time already. So I liked some aspects of PHP, I liked some aspects of Java, but the thing that I was missing in PHP was precisely the Java compiler. So I realized that something similar could be also created for PHP, that it would scan the whole code base and figure out the types and report similar errors to what a compiler does in compiled languages. So I created PHPStan, a static analyzer, which looks into your source code, gathers data, makes use of native type hints, of PHP docs, tries to understand your code, and looks for errors. And some situations are really easy to spot, and others are much trickier. And there's something called rule levels in PHPStan, because I don't want to discourage you when you first install PHPStan and run it for the first time. If it told you everything that's wrong with your code, it would output probably thousands of errors, which would be really discouraging, right? Because you would just remove it and you would never run it again. So with rule levels, I'm kind of simulating how I first developed PHPStan. So I implemented a new kind of check, new kind of rule. And with this single new rule, I ran it on a company's code base where I used to work. And I fixed all the errors, and I merged the fixes, and I continued the work on PHPStan. So with rule levels, I'm trying to kind of simulate this workflow, because when you first run it, it runs on level 0 by default, and only reports the most severe of errors, like creating a new class that does not exist, or calling to an unknown function, and so on. And the idea is that once you clear level 0, you get 0 errors. You should merge and deploy those fixes, and then you should increase the level to get more errors that might be a little bit more involved, a little bit more difficult to fix. And about specifics, you shouldn't really care what's reported on each level. You should just make sure that the number for your code base goes up over time, right? And the big question is which level you should actually use. So I'm not going to go into specifics. As I said, they don't matter. They don't matter much. And you should just know that on level 5, all the basics are covered. All the basic bugs are checked. And every project should at least be able to achieve level 5. Is there someone who is lower than on level 5, like level 0 or level 4? Okay, a few people, so you should be able really to achieve at least level 5. And level 6 is about missing type hints. So without types, PHPStan isn't able to report any errors, because without types, you can really achieve the highest level with 0 errors, because PHPStan is not able to tell you anything about your code. It just doesn't know anything. So running on the highest level without any type hints would give you some false sense of security. PHPStan is telling me that I have no bugs, I have no errors, so my code must be really fine. But if you have no missing type hints, then it's not really true, right? So I kind of shoved level 6 like between the further levels, so that you are forced to add missing type hints into your code. And as you add missing type hints, you will find you will find bugs in your code. So, for example, to get rid of function foo has parameter $a with no type specified, you will add this parameter. You will add the type to the parameter, and from that point on, if someone calls your function with the wrong parameter, you will get more errors, which is actually a good thing because your code is checked. You have more type coverage. Level 7 is about partially wrong unions. So let's say that you have two interfaces or two classes, and only one member of this union has the method that we are calling. So we have foo or bar, and we are calling a method that's only on bar interface. So up until level 5, up until level 6, PHPStan is satisfied with this code because the method exists at least on one of the types in the union. But of course, we can have a bug here, right? If someone passes foo into this function, then PHP is going to crash. So PHPStan reports it, but it reports it on level 7. And the reason why it's not reported sooner is because it might only be in your heads that let's say that you might know that there can only be foo at this point in your code, right? But it's not this information isn't machine readable in any way. It's only in your head because, for example, you might know that this method is only called with products that are already on sale, so it's not possible for some kind of property to be of this type, even if it's type hinted on that property. But PHPStan doesn't know that. It's not machine readable. So level 7 might start reporting something, some information that are not kind of encoded in your source code, that you know only in your head, but to be able to successfully pass level 7, you somehow need to narrow down your types in a way that static analysis can understand. Level 8 is the same point, but about nullables. So you might know that some kind of variable at some specific point in your code might no longer be nullable, but PHPStan doesn't know it, so it's going to report it that you might be calling a method on a nullable, on a type that might be null, and that's reported on level 8. So until PHPStan 1.0, there were only 9 levels, 0 through 8, right? We are counting from 0. We are programmers. So, but the 10th level 9, was added in PHPStan 1.0, and the point of level 9 is that we are stricter about the mixed type. So level 9 is about limiting what you can do with mixed. And up until level 8, PHPStan does not check anything on mixed. If you are using mixed, PHPStan considers your code to be correct. It doesn't report any problem. And it can be really dangerous, right? Because mixed can be anything. So if you are calling a method on mixed, it might be, for example, an integer, and you can call methods on integers. And the reason why it's only reported on the highest level is because our PHP applications are full of mixed types, right? So if you are working a lot, for example, with reading files from disk or decoding JSONs that other people send to you, you have a lot of mixed on your hands. So level 9 is really brutal, and it will give you probably hundreds or thousands of more errors. And you don't have to feel obligated that you have to achieve level 9, because it's really brutal. Not every code base is up to it if you are dealing with a lot of unknown types. But of course, if you decide to make this challenge, if you decide to tackle this challenge, then of course you can. And to give you an idea how brutal level 9 is, not even PHPStan itself is analyzed on level 9. PHPStan itself analyzes on level 8, so that's how brutal I consider level 9 to be. All right, and what I strive for in all of my talks is that you should be able to go back to your job on Monday, and you should be able to apply what you learn here today. So there's this thing called the baseline, and we can thank Dave in the first row for inventing this concept. And the point of the baseline is that if you want to check only new code or changed code with like a stricter set of eyes. So what it does is that you can say that all the current errors that are reported in your code are going to be set as the baseline, and you will be able to disregard them, and only the new errors that you will get from the point from now on are going to be reported by PHPStan. So you can say that the 1,000 errors you currently have are the baseline, and when you and your colleague create a new pull request and they make, for example, 3 new errors, you will only see the 3 new errors. And you can use this feature pretty creatively. So you can use this feature basically to cheat and achieve higher level with zero errors earlier than you would be able to without the baseline. Or you can say, I want to start using this new package, this new custom rule in my code, but I have these 100 violations, but I don't want to deal with these violations right now. I only want to look at my new code and changed code with these stricter rules. So you can use the baseline creatively like that, and I would really encourage you to do that. Okay, so these were kind of the basics, and the title of this talk promises you maximum strictness in PHPStan, so I really need to deliver on that. So from now point on, we will learn about extra packages and extra configuration options that you can use in your code to be even stricter than level 9. But these options that I will be talking about are orthogonal to levels. So even if you are, for example, on level 5, and you like some of the ideas that I'm going to present here about stricter analysis, you can use it alongside any level. You don't have to tackle level 9 first if you don't consider violations about mixed to be valuable for you. You can add these stricter rules even alongside lower levels. So PHPStan strict rules. It's a package that you need to install and include in your configuration. And PHPStan itself does not want to be opinionated because, for example, it might be completely valid that you have an empty call, empty function call, empty statement in your code, and it might be completely valid and intended for you to use. But the empty call is really tricky, so I created an extra package that can afford to be more opinionated about this, and that will not allow you to use some PHP features that you might be normally using, and you might not even realize that they can be tricky to use correctly. So one point of this package is that it just enables some configuration options that are already present in PHPStan, but are turned off by default, are turned to the less stricter variant by default, but strict rules turn them on, so it just reconfigures the core PHPStan behavior to be a little bit stricter. So that's one point of this package. And these options are documented. You can turn them on separately, even without this package, and you can use them, and they are documented on the website. And another point to this package are extra custom rules. So for example, one of the rules is that you should only use booleans in your conditions. So let's look at this code. We are accepting a nullable string, and we are asking if $s. And it might be valid code, but it's a little bit questionable because I have no idea what the developer that wrote this code mean by that. So did they want to eliminate just a null value? Did they also want to eliminate empty string? I really have no idea if what I'm seeing was the intention or if we have a possible bug on our hands. And the problem with passing something that's not a boolean into a condition is that it will use loose comparison semantics in PHP. So PHP is going to cast this value to a boolean. Let's see what it does. So yeah, if we have a normal non-empty string, it's going to return true, except when it contains a 0. So if we have a string with a single zero, it's going to be cast to false. But if we have a string with 2 zeros, it's going to be true again. So if, for example, you are using this piece of code to validate if someone name is a non-empty string, or if it's even a valid name in the first place, then you are discriminating people whose name is 0, but not 2 zeros. So what I prefer much more is writing explicit conditions. So only Booleans in conditions, and I would rather make this more explicit, so I would check, is this thing not null, and is it empty at the same time? And this makes it much more obvious of what's going on. It's much more explicit. So as I said, PHPStan strict rules disallow you to use empty, because empty is in fact this expression. So if you ask, is $a empty? And what you are asking, it might not be set, or it might be false. So empty is going to be silent, for example, about undefined variables. So you can ask, you can probably make a typo and ask about something that never exists. And the problem with the second part is that it uses two equal signs. It uses loose comparison semantics, which are really a minefield in PHP. It's a completely random table. I don't know it from memory. I really don't remember what it does, but from time to time something still surprises me in PHP. Even after all those years, I learned something new. So I don't know, like empty array is equal to null, like why? I don't know. So this is really surprising, and what I would like you to encourage is to use 3 equal signs, because that compares the type and the value at the same time. So only the diagonal, when you are comparing the same type at the same value, is going to be true, which is a little better. So PHPStan strict rules is going to report to you every time you use 2 equal signs or exclamation mark and a single equal sign. And there are also other situations in PHP that use the 2 equal signs comparison semantics. So for example, some functions need a third parameter, need argument set to true in order to use precise comparison semantics. So for example, one of them is in array. So this is going to return true, for example, if the array contains a string that looks like number 1. And if you want to be a lot stricter in your comparisons, you should add third parameter true. So that's what PHPStan strict rules will tell you about. Another thing that strict rules do is that it brings PHP a little bit closer to how compiled languages behave. So this is completely valid code in PHP, and PHPStan itself does not report this by default. So we have a non-empty array. The for each is going to iterate at least once, and what it means is that below the for each, the $v variable is going to exist, and it's going to contain the last element from the array. So some developers prefer to write code like this. They prefer that they can access the last element of the array. They might use it in their logic, and they are not wrong. So by default, PHPStan doesn't report this. But strict rules turn on one of the options from the core to consider the variable as non-existent below the for each. So if you turn on PHPStan strict rules, it's going to tell you that you should not do this, because again, you can only guess the intention of your colleagues or maybe of your past yourselves. If you really wanted to access the last element of the array like this, or maybe you might have wanted access some completely different variable, and it's only kind of a random coincidence that this still works in your code. Another thing that strict rules will discourage you to do is doing dynamic code like this. So PHP allows you to use variables in places that you might not expect. So you can access variables dynamically by their name if you use $2. So this will access a variable whose name is in $s, which is a little bit surprising. And static analysis cannot have any idea what variable you just accessed. So that's kind of dangerous code. And in the second example, you are calling a method dynamically by some kind of dynamic name that's also in the variable. And this is really problematic. This code is very unsafe because we don't know if we are calling an existing method. We don't know if this method has any required arguments. We don't know the type that the method is going to return. So this is very static analyzer unfriendly code that we cannot fully type check. So that's why also strict rules discourage you from writing code like this. Who knows what object encapsulation is? So the idea is that objects shouldn't be breakable, right? Like you shouldn't be able to break some consistent state of an object by calling a method on it. So we usually achieve that by using private properties and some public methods, and these public methods first check that you are really allowed to do what you want to do. And extending a class is also a usage that should honor encapsulation. But when you are writing your class, you probably are not counting on a use case that would forget calling your constructor, because how do you usually start using an object is that you create it, right? And if you extend the class, you should also be forced to call the constructor so that the object can be created in a consistent state. And what people usually forget is that when they extend the class and they write their own constructor, they forget to call the parent constructor. So that's what strict rules will also force you to do. Okay, so if you are not too overwhelmed, we will continue with even stricter options and more possibilities. And they are documented on the website, so you can just follow this breadcrumbs of links to see these options for yourself. And these extra options are not part of any level. They are not part of PHPStan strict rules. You just need to enable them separately if they are going to seem intriguing to you. So one of them is about checking uninitialized properties. So you can, in your configuration file, you can put check uninitialized properties true, and it's going to do something. So it's really dangerous to leave properties uninitialized in your code. PHP allows this, but it's not really safe, because if you create this object and you call the getter before you call the setter, you might have a problem on your hands, right? It's going to throw some kind of error that you are accessing an uninitialized property. And this rule is going to force you to assign this property in the constructor so that you can safely call the getter once you have created the object. You don't have to worry about that someone needs to call the setter before you can safely call the getter. And why this isn't enabled by default is because people love to write code like this, right? So you create an object, and maybe you put some dependency injection attributes in there, and your dependency injection framework might know that after object creation, you need to call it needs to call the setters and so on. So I really don't want to deal with any false positives that people would tell me about, people would report to me. So this is why this is not enabled by default, but you need to enable it yourself. And I am running kind of an experiment. So if you take advantage of read-only properties that were added in PHP 8.1, you don't need this option. In case of read-only properties, this is going to be reported by default. And PHP doesn't require you to do this. In PHP, this code is as valid as before. It's going to work if you manage to call the setter first, but I am kind of counting on the fact that if you have read-only properties in your code, you want to create an immutable object. So you have to have a reason to write to create a read-only property. So for read-only properties, this is reported by default without any extra option needed. All right, if level 9 is not enough for you and you want even more, you can set check implicit mixed to true, and you will get even more errors that related to mixed. So on level 9, you need to have a type hint. It doesn't matter if it's a PHP doc or if it's a native type hint. You need to have a type hint of type mixed. And the first method on top of the screen is going to be reported on level 9. But if you somehow managed to ignore a bunch of errors from level 6 that forces you to add missing type hints, and you manage to achieve level 9, you might not have the type hint, right? So level 9, by default, if you don't have the type, it's not going to report the error. But if you turn on check implicit mixed, it's going to report the error even for missing types. Or maybe you are using some kind of third-party library that doesn't have any type hints, so that's also going to apply on with check implicit mixed set to true. Benevolent union type. It's a union type that's a little bit more benevolent in what it allows. So arrays in PHP are really popular, right? So a lot of people also prefer to use arrays instead of objects. So it's the only single more popular feature than arrays in PHPStan is ignoring errors. So that gives you the idea. That gives you the idea how people use these tools. So you can type hint an array in PHP doc without saying what the keys are. So we just say that it's an array of strings, and the keys are whatever. They can be integers or they can be strings. So by default, PHPStan does not complain if you are passing an unknown array key into some parameter that requires to be precisely an integer or precisely a string. Because you might have a bug on your hands, but it might not be a bug, because we don't really know what the keys are. So by default, PHPStan is not going to complain about this. But once we define a union type that isn't benevolent like this, it's going to error. So if you want to have stricter analysis, even for the first code sample, you can turn on check benevolent union types and set it to true. So if we are iterating over an array with unknown keys, and we want to have an error in these examples, then you need to set check benevolent union types to true. And once you do it, you will understand why it's not a default. So, okay. The next topic is a little bit bigger. It will span multiple slides, so please bear with me. And consider this code. The developer wrote this piece of code, and they rely on person get name on the method returning the same value when you call it a second time, right? So I'm not holding it against them because their code might work completely fine. So that's why, by default, PHPStan does not punish you for writing code like this. It just assumes that you've already checked what the method returns, and it's not going to complain that you might be accessing something that's null, because PHPStan by default considers this method to return the same thing. So this is an example where it works in our favor because it's probably obvious that this code is going to be completely fine. But there are other examples where it might work against us. So we are inside a PHP unit test, and we asserted that person get name is null. Then we set the name, and on the next line we check that it's not null. But basically, because of this behavior, this is a very similar code. PHPStan is going to complain that call to method assert not null with null will always evaluate to false. PHPStan is because of the first assert, PHPStan is going to think that the name is still null. So on one hand, it works in our favor, but on the other hand, it doesn't. So I would like to. I am showing you this so that you can understand when this happens, when this situation happens in your code, and what can you do about it. So this is also, as you notice, this is about pure and impure functions. So function purity is kind of a concept that describes how a function behaves. So function is pure, or method is pure, if it always returns the same value for the same input. And the input is a combination of the state of the object and also the values of the past arguments. And that's for methods, and for functions is just about arguments. And pure also means that the function doesn't have any side effects. And a side effect in a programming language is usually something like sleeping for a few seconds, or accessing the file system, accessing the database, printing something to the output, or depending on time, or asking about a value from a random function, and so on. So function is pure if it always returns the same value given the same state, same inputs, and it's pure if it doesn't do anything, if it doesn't have any side effects like that. Okay, so the default behavior of PHPStan is that functions and methods that return a value are pure by default, so that this piece of code can work as we expect it to. Functions that return void are impure, because if a function that we are not supposed to read the returned value from is pure, then it couldn't do anything useful, right? Like void function always does some kind of side effect, some kind of impure things, changes state, or does something with a side effect. And constructors are pure by default because in most modern applications, the only thing constructor does is that it assigns values to properties. And if you call an impure method on an object, it forgets the state. So this example is going to pass without any errors if setName is a void function, because it will make the person to forget the state, and below calling the setter, the getName might be null or it might not be null as far as PHPStan is concerned. And this is the default behavior, which means that there's probably a way how to override it, right? So you can override it on a one-by-one basis, and the way to override it is with a PHP annotation called PHPStan impure. So if you have something that looks like a getter, it returns a value, but in fact it has some side effects or depends on some global state, then you can mark the method or a function as impure, and it will make PHPStan understand that even if we call it a second time after narrowing the type, it's possible that it's still going to be nullable. So it will make this kind of code work, because we need to have these PHP docs, these annotations, because when you are calling a function, PHPStan does not see its body. It doesn't see the implementation. It only looks at the PHP docs and at the signature, the parameter types and return types. It doesn't go inside the method inside the function, because it would penalize the performance of the analysis. So we need to tell the analyzer what the various properties of functions are with these extra custom PHP docs like that. Okay, so we can override it by case-by-case basis with this annotation, and you can also reconfigure your project globally. So you can set in your PHPStan.neon, you can set remember possibly impure function values to false, and it's going to behave a different way. So it's going to penalize you that you are relying on a function to return the same thing when you call it twice in a row. So if you set this to false, and even if you narrow down the value returned by the getter, it's still going to be nullable when you ask for it a second time inside the if condition. So this is one of the stricter options that you can turn on, and basically it's going to force you to first assign the value into a variable and then continue working with the variable if you want to do that. But it's not the default because people just expect the original example to still work. Okay, so we set this to false, and now sometimes we want the opposite to happen, right? So right now most functions are considered impure, but if you really have a getter and you still want this code to continue to work, to remember what the value is even after you call it a second time, then you can explicitly mark methods and functions as pure with this annotation. Okay, everyone still with me? Okay, awesome. Okay, and I would recommend you to steer clear of these two options. So these options, when set to false, they make level 6 a little bit easier to finish, to make it a little bit easier to get to 0 errors on level 6, and they are about requiring type hints in less places. So if you really want stricter analysis, you shouldn't use these options because it might hide some bugs for you. Okay, so who uses bleeding edge? No one. Okay, so you're about to learn something new. Awesome. So the point of bleeding edge is that when I'm working on the next major version, which is PHPStan 2.0 right now, I don't want to work in a separate branch. Instead, I release the code inside the current stable release, but it's behind feature toggles. It's off by default. So this is a way for me to ship this code without maintaining a long feature branch alongside the main branch where the development of the current stable version happens. And you can turn on these behaviors, and it's great for you and it's great for me because I get early feedback about these new features and these new behaviors, and you get more features, right? So it's a win-win, and you should really enable this, and you should be surprised when you get tens or hundreds of new errors. And when PHPStan 2.0 is released, then this isn't going to do anything because as part of 2.0 development cycle, I'm going to turn all of these, and these feature toggles are going to disappear because I'm pretty sure that what's in bleeding edge I want to enable for everyone. So when the next major is released in 0.0 version, there will be no difference between including bleeding edge and not including bleeding edge. But as development continues and I again add more features to bleeding edge, it's going to be different again. So right now, as of right now, bleeding edge contains about 40 and more different behaviors, and by behaviors I mean how smart the analysis is, what errors are reported, and these aren't enabled for everyone because some of them are BC breaks, and I don't want to break too many people's CI builds, and this is why these are behind the feature toggle. And one of them, for example, is a list type. So list type is a more specific array type. So list type needs integer keys keys as integers in the array, and these keys need to start at 0, and they need to be sequential. So when we are talking about arrays in PHP and arrays in other languages, they are completely different things. Arrays in PHP are like 3 different data structures combined into one, and arrays in other languages are basically lists, right? So they have integer keys starting at 0 with no gaps. So if you want to make your job a little bit easier and you want to rely on something being a list, you can use this list type in your PHP docs. And another example of what bleeding edge enables is that it detects wrong inline at vertex. And people use at vertex for different purposes. It's basically typecasting, right? Like static analyzer doesn't know exactly what the right type is, but I know it, so I'm going to force it with at var sign. And there are multiple use cases, like narrowing the return type. If we know that the thing on the right side of the assignment is wrong out of the box, we can fix it with advar. If some library that you're using doesn't use static analysis and their type hints are wrong, their PHP docs are wrong, you can also fix it with advar. You can use it to tell the IDE what's in the variable. There are many use cases, and I really don't like them, and I want to nuke them from the orbit. So I wish that people didn't use them as often because of the nature that they are using for different use cases. PHPStan cannot report anything about it because the information that PHPStan has might be wrong, and the advar might actually be fixing something, but there's no way to verify that. So I really need to be careful about marking these as wrong, but at least I figure out one case where I can do that. So if you are calling a function that has a native return type, so the native return type cannot be wrong, right? Because otherwise PHP would crash. And you are saying that the type really isn't just a string, but something else. If you are saying that the type is wider than the original native type, that I can be sure that this is wrong, right? Like if we are calling the do function, the return value cannot really be null. So at least with bleeding edge, I can report this behavior. And if you enable bleeding edge and strict rules at the same time, you will also get this reported in a little bit more situations than without strict rules. Okay, and I'm saying that there are 40 new behaviors, not just new rules, because I can afford to do BC breaks in bleeding edge. So thanks to a specific BC break I did, I broke some reference cycles in memory, and I made it easier for the PHP garbage collector to make sense what's in the memory. I made the analysis faster in certain situations. So if you have a huge project with many files and many million lines of code, it might run faster when you enable bleeding edge, because there are no reference cycles. Objects don't point at each other. They only point like in a tree-like structure. They don't point in cycles. So the job of the garbage collector is much easier. And PHPStan consumes less memory. And because the garbage collector basically doesn't have anything to do, it doesn't have to look for cycles because there aren't any. It's much faster on large projects. So this is an example. And when analyzing PrestaShop 8.0 code base in GitHub Actions, when I enabled bleeding edge, it went from approximately 10 minutes to 3 minutes. So if you have a large project, you might see that it's much faster when you enable bleeding edge. Okay, so I hope you are not too overwhelmed, and you will at least enable some of these options when you come back to work. Even with baseline, I would be happy if you enable them and put the existing ones into baseline. Okay, so there is a new elephant coming. This is just a prototype. So you will be able to order it when I release PHPStan 2.0, hopefully later this year. As part of the release celebrations, I will also make this available for order. And I'm saying this now because PHPStan 2.0 will basically be PHPStan 1.x plus bleeding edge plus some BC breaks. So you can already live in the future today if you enable bleeding edge, and but you have to wait until you will be able to order this elephant. Okay, there are many other rules and extensions. So you can go to phpstan.org and follow documentation, user guide, and extension library, and you can see many more extensions that are available. There are many hidden gems in there. And if you are using popular framework like Doctrine, Symfony, or PHP Unit for unit testing, you should definitely install these extensions because they make PHPStan understand these frameworks better. So you will get less errors thanks to the better understanding, but you will also get more errors because there are specific rules included for these frameworks. So for example, if you are who is using Doctrine? Okay, a lot of people. And who is using the extension? Okay, you should definitely install it because, for example, the PHPStan Doctrine extension can validate the DQL queries for you. So it will know when you are accessing a field of an entity that does not exist, that's not mapped. So that's really useful. There are also some third-party rules. So shipmonk PHPStan rules contains about 40 different rules. So for example, if you are using attributes that were introduced in PHP 8, and you always want to create these attributes with named arguments so that you just don't do like parentheses and a value, but you always need to specify like that it's a name or it's some kind of flag or a type. You always need to include a name argument, and you want to enforce this with a static analysis. You can enable one of the rules that's available in this package. This package by Markus Stab is able to infer the types of results of your database queries. So it does it by actually asking your database what these columns are when you are writing an SQL query. It doesn't matter if it's Doctrine debal or if it's directly in PDO. This package has many drivers for many different abstraction libraries. And it's going to know that when you are, for example, selecting name from people or from users, there is going to be an array of strings, which is very useful and is going to make the analysis safer and more precise. Another extension from the same developer, PHPStan to-do by, will look at the to-do commands that you have in your code, and if these to-do commands contain a date, it's going to make the analysis fail after a certain date. So you should look into this. And it also works with some issue trackers. So for example, if the command mentions issue number from Jira or from GitHub issues, it's also going to fail if the issue is closed. So it's really brilliant this way. And last but not least, PHPStan disallowed calls from Michal Špaček it lets you configure it so that you don't leave any unwanted function calls in your code. So for example, if you are debugging your code using var dump calls, or you might have some extra exits in there, you can configure it in such a way that it tells you that you shouldn't really forget these calls in your code. If you want to look for even more extensions, you can use packages.org, and you can just click on the right side in the sidebar for package type PHPStan extension, and it's going to list even more. And if you have an idea for a custom rule and you don't manage to find an extension for this exact idea that you have, you can start writing custom rules, and there's documentation on the PHPStan website, and it's really once you start going and once you start writing custom rules, it's really addictive, because suddenly you don't have to tell your colleagues during code review that they are doing something wrong, but the machine is going to tell them. So it's much more easier to digest an error message from a machine rather than from your colleague. Okay, so a few tips at the end. Always use the latest version. I try to make new releases every time there's a few improvements or bug fixes lined up. So there are usually at least one release once a week, sometimes even more. So you should always stay on top of that because the latest release is always the best one, right? As Apple says. So, and if you are working on a proprietary project, you should have your composer log committed, and you can put a version range using the caret sign into your composer JSON. And you should use some automated tool like Dependabot or Renovate to basically notify you and send you pull requests about new releases that happen. And if you don't have composer log file, if you are working on some kind of open source package that doesn't need this file committed, then you should pin to a specific version of PHPStan. And that's because when someone reports a bug and the bug gets fixed, it makes their build green, but it also can make someone else's build failing, right? So in order to not have your PHPStan version updated as a surprise when you go back to work on Monday and suddenly your CI is running with a different version of PHPStan than before and you might see some failures, it's really better to pin it to a specific version and not forget about automated processes to let it update for you. So you should update your dependencies regularly. And I like to say that it's like visiting a dentist, right? So if you do it regularly, you are fine. But if you are going to update your dependencies only once every 10 years, it's going to hurt a lot, right? Okay, so I work on PHPStan as my full-time job. And I rely on sponsorships from users like you to continue work on it. And I really enjoy it. I really love working on it, so if you can send a few bucks in my way, I would really appreciate it. And speaking of open source sustainability, I have one more thing that I want to show you. And I'm working on something, and I'm really excited about it, and I wanted to share it with you, so here it is. And the idea is that when you use PHPStan, you run the analysis, and for example, you increase the level, and you suddenly have hundreds of new errors being reported. And you focus on a single error, you try to fix it, and then you rerun PHPStan, and it outputs 500 errors again, right? Because you only fixed a certain one. And you try to scroll the results, and you try to look at the same file as you looked before, and you try to figure out if it's there and if you fix the error. And this is not a really nice experience. Yeah, I realized that I was giving a workshop last year at Symphonicon, and I realized this is not a really great experience, right? So there's something I'm working on. It's called PHPStan Pro, and it's presenting a much nicer interface for dealing with the results of static analysis. So it opens your web browser, and it lets you browse these errors in this UI that you can click through, right? And you can just look at the single file, and when you focus on a single error, you try to fix it in your IDE, and then you go back, and you will immediately see if it's going to be fixed. And you don't need to hit refresh, you don't have to hit reload, and because PHPStan Pro is going to continue analyzing your project in the background. So I think that this is a much nicer experience. And additionally, it will also allow you to view ignored errors. So let's say that you inherit a project that you haven't been working on since the beginning, and you want to see what kind of errors are ignored in there, what kind of monstrous lure in that project, so you can see what kind of errors are ignored and maybe do something about it. And you can also configure the interface to always show these errors by default if you really want to focus on your huge baseline and maybe fix some of the errors in there. So you can try this new version of PHPStan Pro if you install the current development version of PHPStan. So you require the development version 1.11.x-dev, and you can launch PHPStan Pro if you just run PHPStan as usual, and you put --pro in there. And of course, the big twist is that this is a paid add-on, because the point of PHPStan Pro is to support the development of PHPStan, and I want to see if I am able to gather enough income to maybe also pay more people to work on PHPStan too. Okay, so the price is €7 a month for individuals, €70 a month for teams, and you basically get 2 months for free if you pay for a year in advance, and everyone gets 30-day free trial. Okay, so that was a little advertisement from me. I hope you like the idea. Maybe you try it, and that's everything. Thank you very much.
Very good. Thank you very much, Ondřej. I've used PHPStan a bit in the past, and I had no idea you were using the feature flags pattern to be able to bring new changes in. That's really cool to see that. Any questions from the audience? No questions. These guys are like challenge accepted. We're going to be level 9 bleeding edge.
About those bleeding edge flags, are they somewhat mapped to the levels, or do I get like all the errors if I enable bleeding edge on level 0 already, or does it?
I think that it does different things on different levels.
Okay.
Like if you enable bleeding edge, it's how 2.0 is going to behave. So it can influence different levels, different ways. Yeah.
Okay.
Any other questions? No, all good. Let's have a big hand. Thank you.
Thank you very much.